All right, so step 1 is H naught H1. H naught is rho equals 0. H1 is
Not equal to
not equal 0. Rho does not equal 0. Step 2, find your critical value. So you're going to use a PPMC table, and you're going to do this nice little picture. And my alpha is, I have no idea what my alpha is. What's my alpha? 0.05. Great, and then what's my degrees of freedom? 6. Because I have 8 pairs minus 2, because I have 2, remember I have 2 variables. And if you're not sure, then look right here in the corner. It says right up here, degrees of freedom for this one is n minus 2, as a reminder. It's right there. So here, your degrees of freedom is 8 minus 2, so it's 6. Your alpha is 0.05, and your critical value is
0.707.
0.707. So you have negative 0.707 and positive 0.707. Third step. What's your third step?
Stat test, Lin-Red.
Oh, so first, tell me which one you put into L1 and L2. So give me that, so I know that you didn't do something weird. Stat test. This is showing your work. Stat test. Lin, Reg, T test of L1, comma L2, and you're going to get R equals
0.7705.
7705, so 771.
Yep.
Throw it in there. And then step 4, are you going to reject or not reject H naught?
Reject it.
Reject H naught. And then step 5,
There's enough evidence to support the claim that there's a relationship between the number of forest fires and the
great.
And then there's also a step 6.
Yeah. Claim correlation or relationship, either one's fine, between fires, number of fires, and acres burned. And then you have that second part, which is going to be, I want to know what to do if my number of fires is 100, what would be my y? And can I use y equals a plus bx, or do I use y bar?
Y equals A plus BS.
Y equals a plus bx, because it is a line. So maybe when you do reject H naught, you can even write is a line if you want. You don't have to, but it will help you out for this part here. And then you're going to say, okay, y equals, what's your a? What did you guys get for a?
Negative 31.6.
Wait, what?
46.
46 plus
1.036.
x. Okay. Perfect. If you did 1.04, that's fine as well. But this is good. 4 sig figs is nice. And then you're going to put 100 in for x, and you're going to get
72.14.
Great.
Yep.
All good? So then you'd say 70.14 acres per.
Well, it would be in hundreds of
Oh,
thousands.
right.
So 7.21 million.
Yeah. 100,000 acres burned. Okay. Good. Perfect. Now, let's go ahead and take a look at 11.1. So notes for 11.1. Does anybody not have their notes for 11, chapter 11? If you don't, I have a couple extra copies. And we'll go ahead and start. How about Edwin? Go ahead and read.
11.1 test continuous with the chi-squared.
Chi-squared. So it's like kite. Kite. K-I. Or it's spelled C-H-I. Go.
The chi-squared statistic can be used to see whether a frequency distribution fits a specific value. This is referred to as the chi-squared goodness of fit test, which tests the claim claim that an observed frequency distribution fits some expected frequency distribution.
Right, good as a fit. So what you observe is what you expect. It fits what you expected it to be. And just as a reminder, so that what we're going to be doing is we're going to assume that O sub I is the same as E sub I. So in other words, for every category, what you observe is what you expected. So if you guys remember our example from last class, we had flavors of soda, right? And so since the flavors for the frequencies for each flavor were from a sample, those are observed. So your observed come from your sample. Observed frequencies come from the sample. The ones you calculate, those are the expected frequencies. You always calculate your expecteds. The observed ones are always the ones from the sample. Those are always whole numbers. Expecteds can be decimals. Right? So you can expect 2.4 kids, but you can never observe 2.4 kids.
Unless if a brutal murder happens.
That would be really disgusting.
Yeah.
Okay. Test for goodness of fit. So this is our formula. You guys remember it? Our chi-squared, that is not x squared. It is chi-squared. So it's the swooshy thing and a slash. Squared. Chi-squared. Not x. And don't find chi and then square it. Don't try to come up with x and square it. It's chi-squared. That's its name. You take the sum, you take every observed value for each category, subtract off what you expect for that category, square that number, divide by what you expected. So however many you observed for cherry soda, subtract what you expected to get for cherry soda, square that number, and divide by how many you expected to get for cherry soda. You do that for every flavor or every category, and then you add them up. That's your chi-squared. Degrees of freedom is number of categories minus 1. So no more n, we're talking about number of categories minus 1. And then you have your observed and expected frequencies there. So let's take a look, flip the next page. And we'll have Frank read.
Expected frequencies, probability of announcing. If all expected frequencies are not equal, then they will be as stated in the problem, and
Expected value, yeah.
expected value equals NP.
Yeah, so we've seen this expected value thing before, right? Expected value of x equals n times p, that was for binomials. It's the same thing. If I have, I flip a coin, what's the and I flip it 10 times, my n is 10. What's the probability I flip a heads? 50, 0.5. How many heads do I expect out of 10? 5, because 10 times 0.5 is 5, right, NP. So that's how you figure out how many you expect to get. You take how many you have, multiply by the probability for that category, and that'll tell you how many you expect in that category. So, keep going.
If all expected frequencies are equal, P equals 1 over K, so expected value equals N parentheses 1 over K, where N is the total number of observations and K is the number of categories.
Right, so all they're saying there is that if they're equally preferred, and I have 6 categories, what's the probability of each category? 1/6. If I have 5 categories, what's the probability of each category? 1/5. If I have 3 categories, what's the probability of each category? 1/3. Make sense? 1 over K. So, and then you just multiply, n times the probability, 1 over K. So if they're equally preferred, you can just take the shortcut. N times 1K is the same as n divided by K. You just do that. Right? 100 people, split amongst 5 categories, 20 in each category. Or divided by 6 categories, and you have 0.1866 in each category, 67 in each category. All right.
1/6 would just be 0.166666.
Oh, there you go. All right, something like that. 1.667 each category. So here's an example. I flip a coin 5 times. Fill this out. What are the categories? If I flip a coin, what are the categories? What can happen?
Heads and tails.
Heads or tails, write them in. So then your K is what?
2.
2. What's probably getting a head?
0.5, 50,
Yep, what's probably getting a tail?
the same.
Also,
So then how many heads do you expect it? Oh, yours says 4, change it to 5.
So then 2 would be wrong.
Yep, 2 is incorrect because it should be flipping a coin 5 times. How many heads do you expect to get? 2.5. No, it's 5 times 1/2. How many tails? 2.5. So expected frequencies do not have to be whole numbers. You can expect to get 2.5 heads and 2.5 tails. You will never actually observe 2.5 heads and 2.5 tails, right? But you can expect that. That can be what you're kind of, in the long run, what you should get. Your observed outcomes, though, are based on experiments, so those are always whole numbers. Those are always what you actually see. Okay? So observe, that's from your sample. It's what you actually see. Those are always going to be whole numbers. Expected, those you calculate. Those can absolutely be decimals or fractions. Here is an example. Michael, go ahead and read.
Education level of adults. The Census Bureau of the U.S. government found that 13% of adults did not finish high school. 30% graduated from high school, only 29% had some college education, but did not obtain a bachelor's degree, and 28% were college graduates. To see if these proportions were consistent with those people who lived in the Lincoln County area, a local researcher selected a random sample of 300 adults and found that 43 did not finish high school. 76 were high school graduates only. 96 had some college education, and 85 were college graduates. At alpha equals 0.10, test to claim that the proportions are the same for adults in Lincoln County as those stated by the Census Bureau.
Great. So we're just going to go to make our table first to make our lives easier. What are my possible categories?
Graduated.
College graduates and not.
Yeah,
Not finished
not high school.
high school,
Graduated from high school. Some college and
college graduates.
college graduates. Everybody okay with that part?
Yeah.
So we have some high school. We have high school degree, some college, and college.
Did you make this up, or is this like a
No, the book found it from somewhere.
that? You know what's crazy? Lincoln County is where I'm from in Missouri.
No way.
Troy, Missouri is Lincoln County. Yeah.
Wow.
Yeah. What a trip, right?
Yeah. That's totally cool.
I know. I didn't think I heard you right at first.
Yeah. 13% did not graduate, finish high school, 30% graduated from high school. So you're going to be like part of that 28%?
I'm hoping.
Yep. All right, so we can write in what our observes are. 'Cause we
No,
have them, right?
because unless he lives in Missouri and commutes here, then no.
Yeah.
You got me. You got me, Martin.
He's going to move back. He's going to go back.
I do
Perhaps.
miss my mom.
But
Yeah.
currently not.
Yeah. All right. So everybody fill in the observes. We give you the observes always. So fill those in. Those are given. Find what was observed. Not sure where to find the observed? Find the sample, right? Observed is the same as sample. Random sample. You're expected to always be kind of based off of percentages. You calculate those. All right, so what do you guys get for your observes?
What's question?
43, 76. Perfect. Now, expected. What do I expect? I expect 13% to have some high school. I expect 30% to finish high school. Everybody look here for a second. Eyes here. Is it fair to compare 0.13 to 43 and 0.3 to 76? No, it's totally unfair, right? It's not, we're not saying that 0.13 of a person is going to be here, or 0.3 of a person is going to be there. What are we saying? How many people we're saying 13%. 13% of what?
300.
Of 300. So you guys kind of follow?
Yeah.
If we don't, so you add up all these, they were nice and they added up for you. That would always be the case. You add up all your sample size and you get 300. So then you take that 300 and you're going to move it down to here. Oops, maybe not like that. And you're going to do 300 times 0.13. So that gives you 39. Here you're going to do, everybody kind of follow? They do the rest. %13 of 300. Means multiply them. You guys should have that. Probably? Yes? No? Maybe?
Yeah.
You can't compare a point to that. That's not good. All right, so this is not 0.13 of a person. It's 13% of the whole. So again, add up your total, 13% of that. What percent of your final is based upon these these 5 sections?
35%.
35%.
Yep.
Your final is 26% of your grade. So roughly 8.5% of your total grade in this class is based upon these 5 sections. Okay. So, no pressure. Well, I'm just saying, pay attention. Right.
There's no pressure, so I can't breathe air.
Right. Oh, that'd be terrible.
crazy.
Don't die. Okay. So let's start with those steps. First step is going to be what? H naught and H1.
Yep.
H naught is always going to be, for these ones,
Equal to and unequal to.
yep, O sub I equals E sub I. H1. O sub I, what you observe is not what you expected. Step 2. Find your critical value. We have our chi-square distribution table. Yep, bust it out. So this one's weird. Even though I told you we weren't going to use this .0251, this problem's strange. It uses it. You may have some homeworks that use it. On the exams, it's not going to be like that. But here you're going to have this. So use it. What's my, how many categories do I have? What's my degrees of freedom?
3.
Yeah, 3. It's 4 categories minus 1. So maybe up here in the corner, you might want to write DF equals number of categories minus 1. You could do that. That'd be okay. All right, just to give yourself a reminder. So it'll be a little bit different for your other parts. Yeah, okay. So here my degrees of freedom is going to be number of categories minus 1. So it's going to be 4 minus 1, or 3. And my alpha is 0.10. So my critical value, oh wait, is that right?
Yeah.
Okay,
Point.
so it's 6.251. Great. The picture for this is a little bit different. You kind of go up, steep, and then you kind of drop off nice and slow. Okay? that's probably right around here. Doesn't matter, just pick a spot. 6.251. Remember, these start at 0. Starts at 0, they're always right-tailed. They start at 0 and they just go up from there to infinity. If you're not sure, look at your little picture here. Right? See the little 0 right there? Saying it starts at 0 then just goes on and out that way. So your table will remind you need it. Step 3. Find your test stat. So, my chi-squared. You have to write out the formula. So this is going to be 43.
Thank you.
So it's the sum of all of your O's minus your E's squared divided by their E's. So the first one would be 43 minus 39 squared over 39. The next, add it, and then your next one is going to be 76 minus 90 squared over 90. You guys see where we're getting these from?
Yeah.
Right, this is the some high school people, right? Observed, expected, squared over the expected. Finished high school, observed, expected there. Do the rest of them. Do some of them. Focus, guys. 2 more weeks and then you have your final. Don't screw it all up now.
This is H naught, right?
Yeah, so the claim quiz will almost always be H naught. Unfortunately, your quiz is like weird, but other than their quiz being weird, they're pretty much, on the exam, they're always going to be H naught.
And then we add all these, convert all these
And
numbers
we add
out.
them all up. 96.
What'd you get for the H?
Minus
What'd you get?
87. Squared. 87.
0.88 1 or 0.83?
What's 3.5? 31.
Oh,
Wait,
yeah,
you got
3.31.
3.5. 3.1. I got 3.5.
I rounded.
Okay.
Yeah, 3.53.
Cool.
See, I get a better I'm all right. What does this
Takes
mean?
so long.
Okay, so what did you guys get?
Oh, what does this mean though? Is that a test?
3.53.
Oh,
3.53. Now, don't forget, you could also, and definitely on the quiz one, when you have 6 of them, and then it's kind of a pain in the butt, if you have more than 4, you probably just want to use your calculator. How do you use your calculator? You do it like this. You put your observed into list 1, put your expecteds into list 2, you need your observed minus expected, so L1 minus L2 squared divided by your expected divided by L2, and you put that into list 3. And then your chi-squared equals the sum of your L3s. Right? Sum of your x's for L3.
And there's a way to do this in the calculator.
If you have an 84.
Oh.
If you have an 83, that doesn't work.
Second list.
And you have.
Second list math sum.
Oh, you could do it that way. Yeah, I was thinking calc 1 of our stats.
Oh, okay.
Since I already know that one.
Okay, that works too.
Yeah. So once you put this into list 3, then you can just do to find your sum of list 3. So you just do stat calc 1 of our stats, right? You guys know that one. And just do it of L3 though, not of L1, or else you're going to run into all kinds of trouble.
I need the GOF test.
Yeah, if you have a fancy calculator, you can just do the GOF test.
Oh.
But the 83s don't have that, and some of the 84s don't have that either. All right, and I'll demo that on the quiz problem. All right, so what do we get? We got 3.53. Where does that go?
That goes before
We get beyond 6.2 or before 6.2?
Like in the middle.
Before.
In the middle.
3.53. Am I going to reject H naught or not reject H naught?
not.
Yep.
There's not enough room for this.
So
I know,
step
right?
5. Do not reject H naught. So that means that we have enough evidence. And remember, for 11.1 and 11.2, our claim is almost always H naught. That it meets some preference. It's the same as some expected value. To reject claim. Now your quiz is a contradiction.
Why are we rejecting it?
Because my claim. Oh wait, I did not. Not enough evidence. Sorry. My bad. Thank you. Not enough evidence to reject claim that percentages are as expected. And that's close enough. I'm okay with that. These get, it's either going to be, you can't say no preference because they're not equally preferred. There are different weird percentages, 30% of this, 29% of that, 27% of that. So when you have that, you just have to say the percentages are, you can list them out, are 16%, 30%, 29%, and 28%. You can do that. Or you can just say, as expected, that's fine too. Frank?
Could you say that proportions are the same?
No, because they're not the same. 30% is not the same.
Same as expected.
Same as expected. You could say that, but you have to say same as expected. Because if you say as same, sounds like you're saying the same as each other. If I said the percentages are the same, wouldn't you think that means the percentages are the same as each other? Right? So that's why you have to say same as expected. Do you understand that? Yeah. Okay, so want you guys take a couple of minutes, 5 minutes, and work on your quiz. Oh wait, do you want to take a break?
Yes.